In this video, we're going to talk about the basic differentiation rules. All the formulas used in this video are provided in the description below. Let's start with the constant rule. Constant rule states that the derivative of any constant is equal to 0. For example, derivative of 5 equals to 0. Let's find the derivative of e squared. That's going to be a constant. That's 0 as well. Derivative of pi is also 0. Derivative of, let's say, sine of pi over 2, this would also turn out to be a constant, therefore it equals to 0. This is the constant rule. Let's talk about the power rule. Power rule states that derivative of x raised to n power equals to n times x raised to n minus 1 power. So let's say we have 5x. What would be the derivative here? Well, the power here is raised to 1. Therefore, 1 is what we bring down. So we have 5 times 1 comes down, which is going to be times by 1, x to 1 minus 1 power. And this equals to 5x to power 0, which equals to 5. Since anything raised to power 0 is 1. Let's say we have 2x cubed. What would be the derivative of this? So this would be 2 times 3x to the 3 minus 1 power. So we get 6x raised to the second power. Let's say we have square root of x. Well, square root of x means it's x raised to the power 1/2. It's better to raise the variable to the power so that it's easier to apply the power rule. We bring down the power and we subtract 1 from it. So we get 1/2 x to the negative 1/2. We could rewrite this as 1 over 2. This is our 1/2 over square root of x. And this is x raised to the 1/2 power. And let's do the last one. Let's get the derivative of x 4th power inside a cubed root. So this equals to x to the, whatever's inside is the numerator, and the outside power is the denominator. So we get 4/3 x to the 4/3 minus 1. So we get 4/3 x raised to the 1/3 power. This is the power rule. Next, let's talk about quotient rule. Quotient rule states that the derivative of f of x over g of x is equal to derivative of f of x times g of x minus derivative of g of x times f of x over g of x squared. Let's do an example. Let's say we're finding the derivative of 6x squared over 2 minus x. Now, we're going to use, to find the derivative of the numerator, we're going to use the power rule. So we're going to get 6 times 2x. So this is the derivative of f of x. Now multiply by g of x, which is 2 minus x, minus derivative of g of x, which is going to be 0 minus 1, so it's going to be negative 1 is the derivative, times f of x, which is 6x squared, over g of x squared, 2 minus x squared. The rest is algebra. Now let's find the derivative of square root of x plus 2x over 7x minus 4x squared. So square root of x is x to the 1/2. So derivative of that is 1/2 x to the negative 1/2. Derivative of 2x is 2. So this is our derivative of f of x. Now we'll multiply this by g of x based on our quotient rule. Then we'll subtract derivative of g of x, which is going to be 7 minus 4 times 2x. This is derivative of g of x times f of x, which is square root of x plus 2x, over g of x squared. The rest needs to be simplified. We have 1 plus x, 1 minus x. What is the derivative of this? Same thing. Derivative of x is 1. We know that. So let's just do it. Let's find the derivative of the numerator. It's going to be 1 times 1 minus x minus derivative of the denominator, negative 1, times the first function, 1 plus x, over the second squared. Lastly, let's go over the chain rule. Chain rule states that the derivative of a function inside a function equals to derivative of the outer function times the derivative of the inner function. For example, let's say we're trying to derive 2 plus 5x squared cubed. This would equal the derivative of the outer function. In this case, the inner is 2 plus 5x squared, and the outer is g of x cubed. This is the outer function. So in order to derive the outer function, we're going to use the power rule. So we're going to have 2 plus 5x squared raised to the power 3 minus 1, which is 2. We just derived the outer function. Now we're going to derive the inner function, which is this part. The inside function derivative of that is 0 plus 2. We bring the 2 down, and we get 10x raised to the power 1. So we get 10x. That's the answer. Now let's do another problem. Let's say we're deriving square root of x to the 5th power plus 4. Okay, let's rewrite this so that we could work with the power better. X to the 5th plus 4, this is raised to the 1/2 power. So we'll use the power rule to differentiate the outer function, which is going to be 1/2 x 5th plus 4. We copy the inner function, and then we subtract 1 from the power, and we get negative 1/2, times the derivative of the inner function, which is going to be 5x to the 4th power. Let's do another example. Let's make it a bit more difficult. Let's say we have derivative of x plus 5x squared minus 2x. This is in parentheses. This is squared, and this is in the 5th power. Now, as you can see, we're going to use the power rule for the outer function, but inside that function we have another function that also has the outer function. So let's see what we could do here. Okay, so let's work step by step. We're working from the outside. So using the power rule, the derivative of the outside is going to be 5 times, we copy everything inside, 2x to the 4th power. That's the outside. Now we're just going to multiply the derivatives inside one by one. So now this is our outside, right? So to get the derivative of this, we have to derive this part first. Derivative of that is going to be, we're working from the outside, so we're going to find the derivative of the outside is going to be 2 times x plus 5x squared times raised to the power 1 times derivative of this inside, which is going to be 1 plus 5 times 2x. Now, we just derived this part. Now we need to derive this part. That's going to be minus 2. That's it. We just derived the outside and we derived the inside.